Welcome back to the Bluewater Auto Restoration Podcast. We're on week 15 now.
Wow.
And today we're tackling a topic that might be a little more interesting than you think at first.
Yeah.
Rust prevention.
Rust prevention, that's right.
Yeah.
And, before the interstate highway system, rust wasn't really a huge concern.
Right.
Cars just didn't see as much road time. I mean, de-icing salts weren't really a major factor.
Yeah.
But once everybody started driving longer distances all year round, things had to change.
Yeah, it's amazing how something like de-icing salts, which are meant to make roads safer, actually created this whole other problem for cars. So what did the industry do? Was it as simple as just like using thicker steel or slapping on an extra layer of paint?
Well, it might seem logical at first, but think of it this way. Would you build a house out of thicker wood and just hope it would stand up to a hurricane?
Okay.
I mean, early attempts at rust prevention kind of had similar limitations.
Yeah.
Just adding more material wasn't enough.
Yeah.
They eventually realized that they needed to approach the problem holistically.
Okay, I'm intrigued.
Yeah.
So what was the aha moment? What really changed the game in the fight against rust?
Well, that would be the understanding of the corrosion prevention triangle: design, materials, and processing.
Oh, yeah.
It's kind of like baking a cake.
Okay.
You need the right ingredients, the right recipe, and the right oven temperature, all working together to get that perfect result.
Yeah.
And if you miss one element, well, the whole thing falls apart.
Right. That makes a lot of sense. So it's not just about like throwing a thick coat of paint on.
Right.
You have to think about the design of the part, the materials that are used, and how it's all put together.
Exactly.
So what were some of the breakthroughs that came from this corrosion prevention triangle realization?
Well, a huge shift happened in the late 80s and early 90s when the industry started using pre-coated steel for body panels.
Oh, okay.
Think of it as building protection into the steel itself during manufacturing.
So it's like baking in the rust resistance from the very start.
Exactly. Rather than trying to add it on later.
Gotcha. Were there any other big leaps forward?
Alongside pre-coated steel, we also started seeing more corrosion-resistant materials like aluminum.
Yeah.
It's lightweight and naturally resists rust, but it can be a bit more expensive to produce.
Right.
Then you've got titanium, incredibly strong, rust-resistant,
Right.
but very pricey.
Yeah.
And of course, we can't forget about plastics and carbon fiber.
Yeah.
Great for design flexibility and resisting corrosion, but repairs can get kind of tricky.
Right. So each material has its own strengths and weaknesses.
Exactly.
It seems like finding that right balance is key.
It is.
So did the innovation stop there?
Yeah.
What else was happening on like the processing side of the triangle?
Well, a big one was the introduction of ELPO coatings,
Okay.
or electrodeposition coatings, back in the 1980s. So this process basically immerses the entire car body in a bath of paint particles.
Oh, wow.
It's like giving the car a full-body suit of armor against rust. It ensures every nook and cranny is protected.
That's a pretty serious defense mechanism.
It is.
But even with all of these advances,
Yeah.
I imagine a car's environment still plays a big role in how well it holds up against rust, right?
Absolutely. You got to think about it. Salt, de-icing chemicals, humidity, heat.
Yeah.
Even those little chips and scratches from road debris, it's a constant barrage of threats.
Yeah. So how do manufacturers actually make sure that their rust prevention methods are working? What kind of tests do they put these cars through?
Well, the gold standard has always been full vehicle testing.
Okay.
Imagine driving a car through salt baths, exposing it to extreme temperatures, even simulating damage from gravel and potholes.
Wow.
But these tests are time-consuming, and they can be statistically challenging.
I can imagine that sounds like a lot of variables to control.
It is.
So did they come up with any faster methods?
They did. Electrochemical testing became a very valuable tool.
Okay.
It's like a miniaturized version of real-world exposure.
Okay.
But in a lab setting,
They expose a small material sample to a controlled corrosive environment, and then they measure the electrical current flow.
Okay.
And this helps them quickly assess how vulnerable the material is to rust.
That's incredibly clever.
Yeah.
But can a lab test really predict what will happen to a car over years of real-world driving?
Well, that's the limitation.
Okay.
It's not always a perfect match for real-world conditions.
Right.
What works in the lab doesn't always translate perfectly to the open road.
That makes sense. So where do we go from here?
Uh.
Is it all about just refining those tests and hoping for the best?
Not quite. We're actually on the cusp of a rust prevention revolution,
Okay.
thanks to virtual simulation.
Oh, wow.
Now imagine being able to predict how a car will hold up against corrosion before it's even built.
Wait, hold on.
Yeah.
We're talking about like building and testing cars in a virtual world.
Yes.
Is this something out of a sci-fi movie or?
Not at all. It's the future of manufacturing.
We can create very detailed three-dimensional models of cars, expose them to all sorts of virtual environments and conditions, and see where potential corrosion issues might arise.
Wow.
This allows us to find and fix problems during the design phase, which saves a ton of time and money.
That's mind-blowing. So this is where all that talk about AI comes in, right?
Yes.
Tell me more about how AI is changing the game for rust prevention.
You got it. We're now talking about developing a virtual corrosion engineer powered by artificial intelligence.
Whoa, okay.
This AI can analyze designs, materials, and processes to predict potential rust problems and suggest the best solutions.
Wow.
Think of it like having a 247 digital expert on hand, guiding you through the entire design and manufacturing process.
That is incredible.
It is.
So we've gone from thicker steel to virtual worlds and AI engineers.
Right.
The future of rust prevention sounds pretty bright.
It does.
What are some of the most cutting-edge advancements that you're seeing right now?
Well, one of the most exciting areas is the use of AI to analyze massive amounts of data.
Okay.
And spot patterns that humans might miss.
Yeah.
It's like having a super-powered brain working alongside human engineers to create the most robust and effective rust prevention strategies.
It sounds like AI has the potential to revolutionize not just rust prevention, but the entire car design process.
Exactly.
So what does this mean for the future of cars? Will rust become a thing of the past?
Well, we're definitely moving towards cars that are much more resistant to rust than ever before.
Yeah.
But will it ever completely disappear?
Yeah.
That's a question for another part of this deep dive.
Okay, you've definitely piqued my curiosity.
Good.
I can't wait to hear more about what the future holds for rust prevention and how these advancements will shape the cars that we drive.
Right.
But before we get ahead of ourselves, let's take a closer look at some of the specific techniques that are being used today to combat corrosion. What's fascinating here is how manufacturers are combining different approaches to create a multi-layered defense against rust.
Yeah, you're right. It's not just about one magic solution. It's about creating a system of protection.
Yeah.
And what the key elements in that system is the use of barriers like waxes, sealants, and even adhesive bonding.
Okay.
To keep those corrosive elements at bay.
Adhesive bonding?
Yeah.
That's not something you typically associate with rust prevention.
Yeah.
Tell me more about how that works.
Well, it's all about creating dry spaces within the vehicle.
Okay.
So think about the seams where like a car door meets the frame.
Right.
By using adhesives in those areas, manufacturers can create a watertight seal.
Right.
So that prevents moisture from seeping in and starting that corrosion process.
So it's like sealing the car from the inside out.
Exactly.
It's amazing how much thought and ingenuity goes into preventing something as seemingly simple as rust.
It is, and we haven't even touched on the environmental considerations yet. You know, understanding the specific challenges that a car will face in its environment.
Yeah.
Whether it's road salt, humidity, or extreme temperatures.
Right.
That's crucial for developing effective rust prevention strategies.
Yeah.
We'll delve into that aspect more in the next part of our deep dive.
Okay. This is all so fascinating. I'm already starting to see my own car in a whole new light.
Good.
But before we move on, I want to touch on one more thing we briefly mentioned earlier, the rise of new materials in car manufacturing.
Okay.
You talked about aluminum, titanium, plastics, and carbon fiber. How are these materials impacting the fight against rust?
Well, it's a mixed bag, to be honest. Each material comes with its own set of pros and cons when it comes to corrosion resistance. Aluminum, for example, is known for its inherent rust resistance, but it can be more susceptible to galvanic corrosion when it comes into contact with other metals.
Galvanic corrosion? What's that?
It's a type of corrosion that occurs when two different metals are in contact with each other in the presence of an electrolyte like water.
Okay.
Think of it like a tiny battery forming between the metals.
Okay.
With one metal corroding faster than the other.
So it's not just about choosing a rust-resistant material.
Right.
You also have to consider how it will interact with other materials in the car.
Exactly.
That adds another layer of complexity to the whole design process, doesn't it?
Absolutely. And that's where careful engineering and testing come into play.
Yeah.
Manufacturers have to meticulously plan how different materials will be used together to avoid creating these galvanic corrosion problems.
It sounds like a delicate balancing act.
It is.
But let's get back to the other materials you mentioned.
Okay.
What about titanium? It's known for being incredibly strong and durable.
Yes.
Does that translate to superior rust resistance?
Titanium is definitely a top performer when it comes to corrosion resistance.
Okay.
It forms a protective oxide layer that makes it incredibly difficult for rust to take hold.
However, its high cost and the complexity of working with it make it less practical for widespread use in car manufacturing.
So it's a bit of a trade-off. Amazing rust resistance,
Yeah.
but a high price tag. What about plastics and carbon fiber? They seem like they would be immune to rust altogether, right? Wouldn't it?
You're right. They don't rust in the traditional sense.
Okay.
But they can still degrade over time due to exposure to UV radiation, chemicals, and other environmental factors. And when they do degrade, it can affect their structural integrity and appearance.
So even though they're not susceptible to rust, they still require careful consideration.
They do.
In terms of their long-term durability.
Yeah.
It seems like there's no single silver bullet solution when it comes to preventing corrosion.
There isn't?
It's all about choosing the right materials, using the right processes, and understanding the environment that the car will be operating in. Exactly. And as we move towards a future of electric and autonomous vehicles, these considerations will become even more important.
Right.
But we'll save that discussion for the next part of our deep dive. For now, let's move on to a topic that's often overlooked but incredibly important.
Okay.
Testing and validating rust prevention methods.
Right.
So how do manufacturers make sure that their designs and materials can actually withstand the real world?
Okay, let's dive into the world of rust prevention testing.
Yeah.
You mentioned full vehicle testing earlier.
Yeah.
Can you walk us through what that looks like?
Imagine a specially designed facility where cars are subjected to a battery of torturous tests. They might be sprayed with salt water, exposed to extreme temperatures and humidity.